I won't dance, don't ask me. I won't dance, don't ask me. I won't dance, madame, with you. My heart won't let my feet do things that
Welcome to your first review lesson. I'd like to take a minute to run through some of the vocabulary and the symbols you're going to need. As you can see, I've filled in some of this chart but left most of it blank. Interval notation is going to involve braces, brackets, parentheses. This one's going to be closed because it has endpoints. You can see -6 to 3. And when you're familiar, the familiar version you are graphing is you should put 2 filled in dots. But I need you to get used to being able to graph using, instead of full-size dots, brackets. For the next line, for interval notation, we're going to use parentheses and a bracket from -5 to 4. This is going to be a half open interval type because we are going to have at least one endpoint, that is at 4. You can see our filled in dot at 4, our open hole at 5, but I need you to get used to a different type of graphing, parentheses and a bracket. For 410, this is going to be an open interval type because we don't have any endpoints. 4 is less than x, which is less than 10, and we could keep getting closer to both of them. The last interval notation is going to be a half open from -10, less than or equal to x, less than 12. The other type of intervals that I'm going to need you to be able to graph are called unbounded intervals. They're always going to include an infinity symbol or the negative infinity symbol. For our first one, a is going to be the endpoint, so it's going to be closed. X is everything that's greater than a. You can see that in the graph. And the second one is open because there is no endpoint. We can keep getting closer to a and closer to a, but we never quite get there. The next one's closed because it has an endpoint of b, but it goes to negative infinity. X can be anything that's less than or equal to b, and you can see that from the graph also. And our last one is going to be open because we can keep getting closer to b and closer to b. X is going to be less than b, but we're never ever going to quite get there. The next topic of review will be scientific notation. I just need you to remember how to convert a number into scientific notation and then out of scientific notation. Numbers written in scientific notation usually take this form. We can rewrite the numbers so it's expressed as a product of two quantities. The first number is greater than or equal to 1 and less than 10. And the second number is an integral power of 10. All right, that's about it. So let's try a few. The distance from the Earth to the Sun is approximately 93 million miles. If I have to write that number in scientific notation, I'm going to break it up into 2 parts. I'm going to move the decimal from where it is at the end, and I'm going to move it 1, 2, 3, 4, 5, 6, 7 times until it's right after the very first integer. And now I'm going to rewrite it. 9.3 times 10, and how many times did I move it? I moved it 7 times. Try clicking pause right now and writing this number in scientific notation. So when I move the decimal from the end and move it to the left, right after the 2, it's going to become 2.6. I moved it 13 times, so 2.6 times 10 to the 13th miles. It's important to be able to explain and demonstrate large numbers if you consider the numbers you see in the newspaper. So, what's the difference between a million and a billion? If I were to give you $1 million and you were to count it out $1 at a time, every second, $1 per second, how long would it take you? Well, I'm going to take a million and divide it by 60 to get to minutes, divide it by 60 to get to hours, divide it by 24 to get to days. So $1,000,000 would take, let's see, divide by 60, divide by 24. That's going to take about 11.5 days. Press pause now and see if you can do the same calculation with $1,000,000,000. So if you had to tell somebody the difference, one takes 11 days and the other takes 32 years. Scientific notation lets us describe big numbers. Click pause now and see if you can express the following numbers in scientific notation. The trick with these two numbers is these are two very, very small numbers. So we're going to move the decimal point to the right. In the first example, we moved it 3 times. And since it's a small number, we're going to write 10 to the negative 3. In the second example, that's an even smaller number. So it's going to be 9.0 times 10 to the negative 8. Click pause now to see if you can write this number in scientific notation. Personally, I don't think either one of these numbers is expressed in a way that would sell anybody. But how about this? What if we told people that a white blood corpuscle is 8/10,000th of an inch? A 10,000th of an inch. Take 8 of them. You know a movie is made up of individual frames. So please click pause now and rewrite the amount of time each frame has to be on the screen in order for you to register it. Again, a very small number, but how small? How would you explain it to someone? I'm actually going to take the decimal and move it 2 times to the left to make it a very small number. 0.06 seconds. 0.06 seconds. But how do people wrap their head around that? Well, they don't like fractions, but let's try this. What if we told them it was 6/100ths of a second? That's how long a picture has to stay on the screen before your mind registers it. Finally, a little challenge if this is all just easy review. Pause now, see if you can work these 4 problems out. When you're multiplying numbers in scientific notation form, try to remember the x is just multiplication. So what if we just made it all parentheses? Now we just have 4 numbers being multiplied together. What if we were to rearrange the order? Like 3 times the 2 times the 10 to the 4th times the 10 to the 3rd. Doesn't matter when you multiply. And now 3 times 2 would be 6. We can do some of this in our heads. We add the exponents. We get 10 to the 7th. And then we can rewrite it pretty quickly in scientific notation. 6 times 10 to the 7th. And if you had to write that as a decimal, that'd be a 6 with 7 zeros. Click pause now. See if you can work this one out on your own. Click pause now, see if you can work this one out on your own. Remember, multiplication you can just rewrite as parentheses. And when you divide, well, 4 goes into 8, goes in twice. When you divide exponents, you just subtract the exponents. So 15 minus 5 is going to get you 10. So I bring down the first number 2 times 10 to the 10th. There's my scientific notation, and now a 2 with 10 zeros. Okay, last problem. Click pause now to see if you can come up with the answer first. And if I write that as a decimal, that would be 3 million. And that's about all you need to know about scientific notation. There isn't everything there is to know, but it's such an immensely useful topic in a variety of subjects. However, for this pre-calculus course, that's all you need. Thank you for your time and attention.
I know that music leads the way to romance.